Bismillahirrahmanirrahim. Assalamu alaikum student. This is Tariq. Today we will discuss the topic quadratic function. The function in which the highest power of the independent variable is 2. And when we graph this function, so the graph is parabolic shape, and the practical importance of the quadratic function that with the help of this function we can define the maximum profit or maximum revenue or minimum cost of the company. The standard form of the quadratic function is as given mathematical notation: y is equal to ax square plus bx plus c. This y is dependent variable, x is independent variable of the function, a, b and c are any parametric constant. A, b and c can assume any value, but with this condition that a cannot be 0. Because if we assign to a value 0, though 0 multiplied by x square is equal to 0, and this total term will eliminate, and now this quadratic function will change its nature. It will change from the quadratic function to the linear function. So this is condition that a cannot be 0. A and b and c are any parametric constant. It can assume any value, but under this condition that we cannot assign to a 0 value. Now, how to graph the quadratic function? So we will follow the following steps. The very first step, concavity of the graph. If the coefficient of x square is positive value, so the graph of this quadratic function will be concave up. But if the coefficient of the x square is negative value, then the graph of this function will be concave down. This is a short way to check the concavity of the graph. Now in the next step, determine y-intercept. So for y-intercept, we know put x is equal to 0 in the given quadratic function. So we will find the y-intercept coordinate or y-intercept point. In the next step, we have to determine x-intercept. Again the same condition. For x-intercept, put y is equal to 0. For y-intercept, we have to put x is equal to 0, and for x-intercept, we have to put y is equal to 0. Now we are coming toward the determine vertex point. So to find the x coordinate of the vertex point, we will put values in this formula. X is equal to minus b over 2a. When we are going to find the y coordinate of the vertex point, we will put the x values in the original function, and automatically we will find the y coordinates of the original function. So what is vertex point? Vertex point is that highest point of the parabola or that lowest point of the parabola at which parabola is a peak out or bottom out. And if we draw a perpendicular line on this highest or lowest point, this will divide, this perpendicular line must divide this parabola into two symmetrical portions, equal shape. So vertex point, the highest point or the lowest point of the quadratic function, we call that is vertex point. Simple. Vertex point, the highest point of the parabola quadratic function, or the lowest point of the quadratic function or parabola, that is called vertex point. Now we are going to solve a mathematical equation, problem number 2. If the quantity demand of a commodity is the function of price of that commodity, as well as revenue of the company is also the function of price. This is wrote in this mathematical problem. And the quantity demand function is as given. This is the quantity demand function, and we give it name 1. Now the question is this: determine the quadratic revenue function, where revenue is the function of price. So to determine the quadratic revenue function, we need linear revenue function. The linear revenue function I developed, total revenue is equal to price multiplied by quantity. The highest power of the each variable is 1, and this is the sign of linearity, that this function that we developed, that is linear revenue function. Why I needed to develop the quadratic total revenue function? Now we will put the function number 1, demand function, quantity demand function, we will put in the function A, linear function. So when I am substituting for Q its value, so P multiplied by 100 minus 25P, and now we will multiply this P inside the bracket, so 100 ZBP, 100P minus 25P ZBP minus 25P square P murabba. Now the highest power of this function is 2, independent variable is P, dependent variable is total revenue TR. This is a quadratic function where the value of A is minus 25 and the value of B is 100 and C is actually 0. So we develop the quadratic revenue function. The highest power of this function is 2. The values of A, B, C are also clear. Now the second part of the question is this: determine the quantity demand intercept. So we know for y-intercept x must be 0, for x-intercept y must be 0. And here we will put P is equal to 0 and 1 to find the quantity demand intercept coordinate. Quantity demand 100 minus 25P, and P is what? For y-intercept x must be 0, and here y is quantity demand and price is independent variable. So for the quantity demand we have to put P is equal to 0, and this will give us the quantity demand intercept coordinate or the quantity demand intercept value. And quantity in demand intercept point carry 2 value, price is 0, and at that 0 price the quantity demand is 100. Now the third part of the question: what is the total revenue if suppose the price of the commodity selling price, that is 10. So again we will put this price 10 in the revenue function. Total revenue is equal to 100 P minus 25 P square. When we put in here and solve, so we will find the total revenue. 100 multiplied by 10 minus 25, price is 10, 10 square. So 100 multiplied by 10 is equal to 1000, and minus 25 multiplied by 100 is equal to minus 2500, and the difference of both values, that is minus 1500. So this is the way to compute the total revenue. When we put the price in the total quadratic revenue function, automatically we will find the total revenue of the company. I interpret this total revenue which is negative, and there is no business which is working for negative revenue earning. No, everyone want to earn more, more and more. So why this revenue, calculated revenue, is negative? The reason is this, that maybe the price that is prevailing, that $10, that is not revenue maximizing price. This is very high price or very low price, and in both cases, if the company is increasing price, revenue will decrease, and if the company is decreasing price too much, again revenue will decrease. Because when the price is very high, so quantity demand will decrease, the company will lose the customer, and automatically when no one is purchasing, so how revenue will come? And other is this, that if you are decreasing the price, so this is also possible that many substitutes are available for your product. So if you are decreasing, still the people are not purchasing your price, so that is why you are losing revenue. Interpretation is this, that this price at which the revenue is minus $1,500 billion negative revenue, that is not maximizing revenue price, may be very high or may be very low. The next, that is, what is quantity demanded if the price is 10. So again we will put the value of P in the demand function 1, put P is equal to 2 in first function. We have demand is equal to 100 minus 25 multiplied by 10, because the price is 10 and this is demand function. So when we multiply 100 minus 250 and minus 250 plus 100, that is equal to minus 150. So again this is very clear that when the price is 10, at this the demand calculated negative, it means the people are not interested to purchase at $10 this product. That is why the revenue and demand of the company both are negative. Price is very high, this is not revenue maximizing price, no one is ready to purchase at $10. That is why the quantity demand is negative, and when the quantity demand is negative, people are not demanding, definitely revenue will be negative, company will be in loss. Now we are coming again toward the interpretation. Negative quantity demand means price is very high, no one is purchasing, that is why demand is negative. Determine the concavity of the function. So as a is minus 25, the coefficient of x square is negative, so graph is concave down. Note, if the coefficient of the x square is positive, so graph is concave up, but if the coefficient of x square is negative, then graph is concave down. Determine the price at which total revenue is maximum. The hint is this: we can use the vertex points to determine the price at which the revenue will be maximum. So let me briefly tell you that when there is a question that you have to define the highest revenue or highest profit or maximum profit or minimum cost, so you have to recall in mind the vertex point, because vertex points are the highest point of the parabola, concave up or concave down. If this is concave down, so vertex point is maximum highest point, but if this is concave up, then vertex point is lowest point. That is why to define the price at which the revenue of the company will be maximum, this is possible. So we are using the formula x is equal to minus b over 2a. Using this formula, we can define the x coordinate. In here in the quadratic revenue function, this is applied example. So for x we have p, where x is price in this total revenue function. So p is equal to minus b divided by 2a. B is 100 minus 100, this A is minus 25, minus 100 divided by minus 50 is equal to, price is equal to 10. We calculate the price is equal to 10 with the formula x is equal to minus b over 2a. We substitute the values from the quadratic function and we find out the price. P is equal to 2, and this is the price at which the total revenue of the company will be maximum. Now put p is equal to 2 in the original function to find y coordinate of the vertex point. When we find first coordinate p of the vertex point, we will put the value of that p in the original function. We will get the y coordinate of the revenue function. So y is the total revenue in this function. We are putting the value of p in this revenue function, tr 100p minus 25p square. Now 100p is a 2 minus 25, 2 raised to the power 2, and 200 minus 100 is equal to 100. So it's mean when the price we define to, demand of the people will increase and the revenue of the company will increase to the highest point. So determine the price at which total revenue is maximum. Keep in mind we will use the vertex point, and how we can find the vertex point coordinates. For x coordinate minus b over 2a, put the values, find the p, and then put this p again in the original function. We will find the total maximum revenue as we did it. Now interpretation, the revenue is maximum at the price p is equal to 2 that we define, that we determine. Now we are going to graph the total revenue function. This is the total revenue function, 100p minus 25p square. This is a quadratic function, the highest power of the independent variable p, that is 2. Now we are answering this, graphing this using the steps. In the very first step, we will check concavity. So the coefficient of x square mean p square is negative. That is why the graph is concave down. Step 2, we have to define the revenue intercept. For the revenue intercept, condition is this, that p must be 0. So when we put p is equal to 0 in the total revenue function, this is as total revenue 100p minus 25p square. This is total revenue quadratic function. Total revenue is equal to 100 multiplied by 0 minus 25 multiplied by 0 raised to the power 2. 0 minus 0 is equal to 0. When there is no price, when there is 0 price, so nothing is coming, no inflow of money into the organization. That is why revenue is 0. For price is equal to 0, revenue is also 0. Now we are going to determine the total revenue intercept points, that is 0 and 0. In the next step, define the XRP intercept point. XRP intercept point will carry two values, one is price and other is total revenue. So put the y is equal to total revenue is equal to 0 in the function z. Function will automatically change from the quadratic function to quadratic equation, and then we have to solve this quadratic equation for p. So to determine the p-intercept or x-intercept, we have to put y means total revenue equal to 0. In here, this is applied example. For the x we have price, and for the y we have total revenue. So to determine the p-intercept, we have to put the total revenue equal to 0, and when we this put equal to 0, this function will change from function to quadratic equation. Now we can solve this quadratic equation using quadratic formula, or using completing square method, or using factorization method. So I am showing practically total revenue, quadratic revenue function 100p minus 25p square, and now for the p-intercept I have to put the total revenue equal to 0. So I put this 0, and now we have to solve for p. So solve for p using factorization method or quadratic formula. Factorization method, 100p minus 25p square. Now p is common, so taking p common, we have, when we take the p outside, here remaining 100 and here remaining minus 25p, this is equal to 0. Now put each factor separately equal to 0 and solve for p. These are two factors. We factorize this quadratic revenue function. This is first factor p, and this is second factor 100 minus 25p. Now to find the value of p, we have to put each factor separately equal to 0 and solve for p. So the first one, p is equal to 0, there is no need to solve. And the next one, 100 minus 25p, we put equal to 0 and we solve for p. We add 25 to both sides of the equation. We have 100 minus 25p plus 25p is equal to 0 plus 25p. So 25p cancel out 25, here remaining 0, and 100 is equal to 25p. Now we will divide both sides by 25. We have 25p divided by 25, 100 divided by 25. So we find out p is equal to 4. So now we have two values of p. One is a 4 and other is 0. 4 and 0. So put 0 in the total revenue function. The result will be definitely 0 because price is 0. So revenue is also 0. Now put p is equal to 4 in original total revenue function. For p-intercept, total revenue or y must be 0. Now total revenue is equal to 100p minus 25p square. When we put total revenue 100p is 4 minus 25 into 4. So 400, and this is minus 400. So revenue is equal to 0. It's mean that we define the p-intercept value, and for p-intercept this was condition that revenue must be 0, and when we put revenue equal to 0 and then we solve, so we find the p values. One is 0 and other is 4, and now this is shart that for p-intercept total revenue or y must be 0, and when we put the p is equal to 0 in the original function, we find total revenue equal to 0, and when we again put p is equal to 4 in the original function, we again get total revenue equal to 0. So that is why condition satisfied that for p-intercept y means total revenue must be 0. Step number 4, define the vertex point of the quadratic revenue function. So vertex point as I defined, the highest or maximum point along the graph of the quadratic function. that is called vertex points, are the lowest point along the graph of the quadratic function, that is called vertex point. When we draw a perpendicular line on these vertex points, so it must divide the parabola into two equally portions, into two same shape. On these points, it will divide parabola into two symmetrical portions. To find price coordinate value of the vertex point, use formula. Now look, to find p coordinate value of the vertex point, we can use formula p is equal to minus b over 2a. A is b is 100 and a is minus 25, so minus 100 and minus 50, so p is equal to 2. And now put p is equal to 2 in the original function to find the total revenue coordinate value of the vertex point. So we are putting here p2, again p2, this is 200 and 2 raised to the power 2, 4, 200 minus 100 is equal to 100. Vertex point coordinates values, vertex point 200. So in this section we learn that vertex point, what is vertex point? Vertex points that point along the quadratic function or along the parabola which is highest point along the parabola. Simply the highest, the maximum point along the graph of the quadratic function or the minimum point along the graph of the quadratic function, that is called vertex point. When we divide this vertex point by line, so this line will divide vertex point perpendicular line into two equal portions. And how we can find the x coordinate of the vertex point? Using this formula. P is equal to minus b over 2a. We substitute for b 100, for a minus 25, and we find out the p coordinate value of the vertex point. Now to find the y coordinate or total revenue coordinate, we will put this p value that we defined in the original function as I put here. Price is 2, 2 raised to the power 2, price is 2, 2 multiplied by 100, 200, minus 25 multiplied by 4, that is 100, 200 minus 100, total revenue 100, vertex point coordinates values were 2 and 100. These are the vertex points.